Okay, so we're gonna do our last pass on the treadmill. And as you see, is X, Y, and Z. The thread that I'm doing is 1.1885 Acme, and I'm using a treadmill which is, as you see, SPTM 125 up to, so technically 5 Acme, between 1 inch and 1 inch and a quarter. You get a closer look on the treadmill. So this goes, so first one's a little bit smaller, then it goes a little bit bigger and bigger, so you got a couple cutting flutes. And the angle is also compensated, so when it goes inside of the spiral, your edges are perfectly 60 degrees. If it's a 60 degrees, but the geometry of the treadmill, the compensation. So this is a bigger treadmill. Like for example, this is a different brand that this company uses, Carmax. This one, it's at 1.5 millimeter. Kind of pull it out of the case. This is a little bit different. It's obviously way smaller. So the ID of this thread is a little bit under 1 inch. So it's gonna show you minor. Let me see. So 997, I cut it down to 995, and major it's up to 1 inch and 227. I had to go a little bit deeper. Let's review the program. So I broke it down into 3 sections, 1, 2, and 3, because this is a big thread. Usually you could get away with 1 or 2. So all of them, technically everything is the same. The only difference is going to be the diameters. Okay, and this, the diameter of the actual treadmill is 625. So I set it as an end mill 620T. So if I see 620T end mill, then I know it's a treadmill with a diameter of 620, right? Same thing as my ACT is 620. You can control this the depth with the ACT, but in this instance I control it with a program. Okay, so let's go over it. Circle mill XY, position C0, tornado, the final diameter. So the first diameter, we're going 1 inch and 140. Sorry. So 1 inch and 140 is the outside diameter. The second one is 1 inch and 190. And the last one was 1 inch and 240. So I'll drop it about 50,000 per pass. My depths are the same, so I'm going 1 inch and 100. The part is about 880,000. Plus I'm going additional over a little bit over 200,000, so it clears the back of the part, the chamfers and the bottoms, and these are very important. You gotta zero these out. And then the pitch, first pitch is always 0. The second pitch it's gonna be 200. So if you have a number 8 thread, the pitch will be 125,000, right? But since this is a thread number 5, so 1 divided by 5, it's 0.2. So this is where you put your pitch in your thread milling. So now with the tool sequence, okay, we got 620T, the whole number and the whole depth, that's being changed from here. This is what the machine is reading. This is what you're gonna usually see on your tool path. Counterclockwise, roughness 5. I usually always do that. Then your surface speed 200. My feed rate is 8,000. You actually, this is kind of crazy because usually you put feed rate for your threads, but in this instance, the feed rate I usually go with the 8,000 M coolant. And my point is, I'm starting from a 0, C0, Z0, P and R, they're all zeros. So technically, most of the information you're gonna fill is here. So this one is important, your final diameter. Like I said, so my final diameter is 1 inch and 240. I'm going 1 inch and 100. Clockwise, roughness 5. Surface speed and your feed rate, and the second pitch, it's gonna be your pitch. And the chamfer and the bottom just use 0 and 0. And this is technically how you thread mill. Thank you guys for watching, and see you next video.